Dividing fractions. In this video, we will compare two methods you can use to divide a fraction by a fraction. Our first method is to multiply by the reciprocal. You may ask, what is a reciprocal? Well, the reciprocal of a number is the multiplicative inverse. What that means for you is, you take a fraction and you flip it. So 1 over 4 becomes 4 over 1. The multiplicative inverse is created when you multiply them together and get a product of one whole. I'm going to model that for you. To allow the modeling to be a little bit clearer, I'm going to take 4 over 1 and change it to 4. Remember, 4 over 1 is equivalent to 4. Now I'm going to take a quarter piece, a fourth fraction here, and I'm going to repeat that pattern 4 times. Once I have all my pieces, I'm going to go ahead and put them together. As I piece them together, I hope you are seeing what is happening. When I take 4 1/4 pieces and put them together, they create a whole. Mathematically, I'm going to change the 4 back to 4 over 1 so that we can multiply the numerators and multiply the denominators to get 4 over 4. What does 4 over 4 equal? You guessed it, 1 whole. Let's look at another example. Here we have 2/3. Think about its multiplicative inverse, or flip. 2 over 3 becomes 3 over 2. Again, we're going to multiply the numerators, then multiply the denominators, and get 6 over 6. Again, what does 6 over 6 equal? You guessed it, a whole. Now we're going to talk about math as a language. Here I have a problem 3/5 divided by 1/4. There are actually 3 different operations in this problem. How, you may ask? Well, 3/5 is also known as 3 divided by 5, and 1/4 is also known as 1 divided by 4, because your division symbol and your fraction bar are the same thing. So if I was going to read this problem, it would read 3 divided by 5 divided by 1 divided by 4. Whew, that's complicated. Is there a way we can make it simpler? 3/5 divided by 1/4. I'm going to take this problem and turn it into a mega fraction, which means 3/5 over 1/4. Whew, that sure looks complicated. How can we simplify this problem? Well, let's think back to the reciprocal, and remember, if I take a fraction and multiply it by its reciprocal, it gives us a product of 1. This is going to be very helpful for the denominator. Looking at 1/4, we multiply it by 4 over 1. This will give us 4 over 4, which we know equals 1. Now don't forget, whatever you do to the denominator, you must do to the numerator in order for it to be equivalent. So I'm also going to multiply 4 over 1 here. I just do the math, and I get 12 over 5. What we can remember is, if you divide a number by 1, it just gives you itself. So here we end up with an answer of 12 over 5. This method is often referred to as keep, change, flip. But to use the proper mathematical terminology and to help you remember what this actually does, we're going to change this wording, or use the proper wording, to multiply by the reciprocal. We take 3/5, and instead of dividing, we multiply, and instead of using 1/4, we use the reciprocal. So again, this method becomes multiplying by the reciprocal. 3/5 multiplied by the reciprocal gives us a new problem of 3/5 times 4 over 1. Let's model this. Here I give you 3 shaded pieces out of 5. 5 would be the whole, 3 shaded, and I repeat that pattern 4 times. Now let's count up and look at our pieces. The shaded number of pieces are going to represent the math of 3 times 4, which gives us 12. Then, in order for a whole to be completed, we would need 5 pieces. That is our denominator. I have this improper fraction which gives me 12 pieces, but in this model, there is not a whole completed. So we're going to move the pieces to complete the whole. Here this row is done, 5 out of 5, there's 1 whole. Move more pieces, there's a second hole completed. And then what's left over? 2 out of 5. So 12 out of 5 is equivalent to 2 2/5. The next method we are going to look at is using a common denominator. 3/5 divided by 1/4. We have a denominator of 5 and we have a denominator of 4. Some of you may already know what the common denominator is. Some of you may list out multiples. I'm going to look at the multiplication chart to find the common denominator. I look at the row for 5 and I look at the column for 4 and I find the first number they have in common. In this case, it is 20. We're going to set up our equivalent fractions. 3/5 is equal to what over 20, because that's what we want our new denominator to be, and we're going to do the math. In order to get to 20, we have to do 5 times 4, so we do the same thing on top, and we get 12. We're going to do the same method with 1/4, except we multiply by 5, and we get 5. So, our equivalent fractions are 12 20ths and 5 20ths. So now we're going to divide 12 20ths divided by 5 20ths. Here's a model. First I have shaded 12 out of 20. That's what size 12 is out of 20. Now I have 5 out of 20. This is the size that represents 5 out of 20. The question is, how many times can this 5 out of 20 piece fit inside that 12 out of 20? Well, here we can do one whole piece. Here we can do another whole piece. But over here, we only have 2 shaded pieces out of 5. Therefore, I get an answer of 2 2/5. Mathematically, we are simply dividing the numerators and dividing the denominators, giving us 12 divided by 5 over 20 divided by 20. Of course, 20 divided by 20 is going to give us 1. And we know that any number divided by 1 is itself. So we end up with an answer of 12 over 5. For those of you who may have forgotten how to turn an improper fraction into a mixed number, mathematically, I'm going to show you that right now. 12 over 5 means 12 divided by 5. We can make 2 whole groups using 10 pieces, leaving us with 2 out of, draw a line here, 5 as our fraction. So we have an answer or equivalency of 2 2/5. Here we are comparing the two models we have looked at in this video, using the common denominator and multiplying by the reciprocal. Although the models do look different, there are a lot of things they have in common. The 12 are the number of shaded pieces, and the 5 is the denominator or the pieces used to create the whole. Now our answers, one is in mixed number form, 2 2/5, and the other is in proper form, 12 over 5, both of which are equivalent. Next, we're going to see these two models or methods compared side by side mathematically. When dividing fractions, which method is easier? Do we multiply by the reciprocal, or should we use a common denominator? In the problem, 2/3 divided by 1/6, we're going to start by multiplying by the reciprocal. We often call this keep, change, flip, because we keep the first fraction, we change division to multiplication, and then we use a reciprocal or the flip of the second fraction. After we've done that, we multiply the numerator, 2 times 6 is 12, and multiply the denominator, 3 times 1 is 3. That's an improper fraction, so we need to go ahead and do the division, 12 divided by 3. In this case, we get 4 wholes with nothing remaining. For the common denominator, we look at 3 and 6. You should know that the least common denominator of 3 and 6 is 6. So in order for me to create an equivalent fraction, I have to multiply the numerator and the denominator by 2. This gives me 4/6. Then I divide that by 1/6. Looking at just the numerators, we have 4 divided by 1. The denominators show 6 divided by 6. This math gives us 4 over 1. And we know that any fraction with 1 as the denominator is a whole number. So both methods give us an answer of 4. You choose the one that's easiest for you.